function that we're starting with here, f of x equals x squared plus 6x plus 4, is in standard form, where a is 1, b is 6, c is positive 4. To convert that to vertex form, we want to end up with something that looks like this: a times the quantity x minus h squared plus k. And when you get it in that form, it's easy to identify the vertex. The vertex will be at hk. For example, if you have y equals 7 times x plus 5, the quantity squared minus 2, the vertex will be at, well, this has to be a minus sign here, so you have to think of this as the opposite of negative 5, which would be, so the vertex is at minus 5 and k is minus 2. Question is, what do you have to do to this function in standard form to get it in vertex form? Well, when the leading coefficient is a 1, it's pretty easy. You have to go through something called completing the square. And one way to visualize this is to kind of separate the constant term out here to the right. And then you probably wouldn't go to all this trouble on scrap paper, but to complete the square, we're going to add a number in this red space here that makes the first 3 terms a perfect square trinomial. And since we're going to add a number here, we have to subtract the same number over here to keep the equation in balance. How do you complete the square? When the leading coefficient is a 1, you take half of b, which in this case would be 3. 3 squared is 9. That makes this a perfect square trinomial. And if we add 9, we have to subtract 9. So y equals, now write this as x plus 3, the quantity squared, minus 5. And when it's written in that form, you can identify the vertex easily as negative 3, comma, minus 5. Since the number out here, a, or even when it was written this way, is positive, in this case a 1, this is an upward opening parabola, and it will have a minimum value at the vertex. This minus 5 is the minimum value that this function ever achieves. Now let's go to Desmos just so you can see. Here I've graphed the original function in standard form, f of x equals x squared plus 6x plus 4. There's the vertex. If I hide that one and enable g of x, you get the same function, same graph, either way. So standard form, vertex form. Okay, now when the leading coefficient is other than a 1, there's a little more thought involved, especially when you have to figure out what to subtract here at the end, but we'll leave that for another time.